We're going to apply what we were working on yesterday to actually solving quadratics, okay? Factoring itself is not something that I'm actually going to assess you on. Your ability to use factoring in order to solve a quadratic is what I'm going to be testing you on. Now, obviously, knowing how to factor allows you to get to the answer more quickly. We've solved quadratics only one way so far. We've used our graphing calculator. We checked out where the graph crossed the x-axis. Those x values were our solutions. Okay, now today I'm going to show you how to solve a quadratic without necessarily graphing, but you can use the graph to reinforce whether or not your solutions are correct. And one of the things I want to do today is connect the graph of a quadratic to the solutions found by factoring. So this is on page 570 in your book if you would rather screenshot from your book. There's a lot going on here, but it's all connected together, and when we can find the solutions of a quadratic, we can find them in a couple different ways. Okay, so go ahead and get that in your notes, and then we'll keep going. So there's a lot going on this screen, right? If you took the original equation in standard form, 0 equals x squared minus 8x plus 12, and you put that in your calculator, you'd get a graph that looks like this. Okay. From what we learned in 4.2, what are the solutions from this graph? 2 and 6. Okay. So that's where the x-intercepts are. My solutions are 2 and 6. Now something sort of new, but maybe you've seen it before, is this over here. Okay, this is basically taking this equation and factoring it. All right, finding the factors of 12 that add up to -8. Those are -6 and 2. This is known as factored form. And when we're trying to solve quadratics by factoring, our goal is to get it down to factored form. Now, the solutions are 2 and 6. If you notice on the inside here, okay, the signs are opposite. It's actually -6 and -2. And I'm going to explain why that is here in a minute, but that's the connection. Okay, the connection is that the actual solutions are opposite signs from what's in the equation of factored form. Okay, and it's this equation that we're talking about, the factored form equation. Because our solutions are actually +2 and +6, but in the equation they're negative. And we're going to talk more about why that happens here in a second. So just to connect it even further, okay, notice here that, again, you have the signs, they're opposite from the solutions, and again, the factored form, that's the opposite, okay? When we get in, we'll get a little further with this, I'll explain why. Actually, no, let's explain why right now. Anybody have a guess why it's opposite? Anybody know why it's opposite? Yeah, what do you think?
Because if you were to solve it, you would add it for both sides. So well, I don't know how to describe it, but
No, you're on the right track. All right, hold that one. You want to finish kind of what he was saying?
So you would subtract it over the equal sign. So if it was positive, you'd cancel it out. So x equals
Here's what I think you guys are both trying to say. Let's write. So that's why this whole opposite sign thing works, because in order to make this a true equation, if I plug 6 in, this becomes 0, and 0 times anything is 0. Or if I plug 2 in, this becomes 0, I plug anything. So that's really why the opposite sign thing works. Because once we have it into factored form, we're trying to figure out what values will make each binomial equal to 0. Okay? All right. Now, we can go the other way. So what I mean by that is, here I had an equation, and we found the solutions. If I give you the solutions, this equation out, and I'm going to write it like, the equation is like this, right? It's saying I'm multiplying one thing by another thing, and my answer is what? When I multiply those two things together, what do you get? 0. So in order to multiply two things together to get 0, what does that mean? One of them's got to be equal to 0, or both of them are equal to 0. And so what we do is we really just, we really set x minus 6 equal to 0, and we set x minus 2 equal to 0. And so what you guys are talking about with an equation, I'm adding 6 to both sides, so x equals 6. Or I add 2 to both sides, x equals 2. There's your opposite sign, because when you plug it in, then it makes this term 0, or it makes this term 0. You can write an equation. Okay, and so we're going to walk through this and think about that opposite sign thing. Because, for example, the solution x equals 2 changed to factored form x minus 2. The solution 6 changed to factored form x minus 6. So this problem really starts off like that. Since my solutions, my roots, are 3/4 and -5, in the binomial, instead of being positive 3/4, it's going to be minus 3/4. And instead of being -5, it's going to be +5. And since we're writing an equation in standard form, that's how we start off. Just like this. Okay? X minus 3/4 times the quantity x plus 5 equals 0. Again, that whole opposite sign idea. And the reason being is if I put 3/4 in for x, this becomes 0. If I put -5 in for x, this becomes 0. All right, is this in standard form? What is standard form? What is standard form of a quadratic? Kate, what is it? Standard form of a quadratic. Do you remember?
Ax plus by. Wait, no.
Yeah, you're on the right track. Yep. Somebody want to help her? Yeah? Go ahead, Hayden. Yep, ax squared plus bx plus c. Good. Okay, so we have to get this in that form. What kind of form is this? I just showed you about it on the other slide. What's it called? Factored form. Good. Okay. So in order to put it in ax squared plus bx plus c form, what do you think I have to do? Unfactor it, yes. What do we call unfactoring? Distribution, yes. In this case, what do you usually call it? FOIL, yeah. So FOIL that out, please. Yes, with the fraction. All right. So when we FOIL this thing out, eventually you get this. I skipped some steps. Okay. The middle term would have been 5x minus 3/4 x, which of course is 17/4. Now, is this in standard form? What was true about A, B, and C? What couldn't they be? Fractions, no decimals, so we got to keep going here. Okay, so when we're talking about standard form, that means no fractions, no decimals. Now I've taught you how to get rid of fractions. What am I going to have to do to get rid of these 4s? Yeah, times everything by 4. Now, the other thing, and I'll show you this in a second. So if I just multiply by 4, okay, then this becomes 4x squared, and these 4's cancel out, and we get 4x squared plus 17x minus 15. Let me show you kind of another way that you could do it, and it has to do with that slide divide bottoms up, right? Because the solution for this binomial, if I slide the 4 up like that, the solution for this will still be 3/4. If I plug 3/4 in here, then the 4's cancel, I have 3 minus 3. So you could, if you want to use the idea from slide divide bottoms up, if you've been using that for your factoring, to change this binomial to here, then you can avoid all the fractions. Because when you FOIL this out, you'll go right from here to here. I'm guessing you like that idea and not having to deal with these fractions. So that's the one tip I'll give you. Okay, if you use the slide divide bottoms up idea there, then you can go straight from this to this without having to do any of this stuff in the middle. Okay, just know that that's an option for you. If you want to use it, great. If you don't want to use it, great. It's your choice. Okay. All right. Now let's actually solve by factoring, because that's the point today. We can create equations from solutions. We can pick off solutions from factored form. Now we're going to start with equations that are just going to be quadratics that we have to solve by factoring. One of the things that I'm just going to warn you about, because this happens every year on the test, I will give you questions where it says solve by factoring. What you guys did on your worksheet yesterday was not solving by factoring. You were just factoring, only factoring. There were no equations. There were no solutions. They were just simplifying it into factored form. That is not solving. That is just factoring. The key word to everything we're about to do is solving. Okay? And just like what we did in 4.2, we solved those by graphing. We are going to solve these quadratics. We're going to get an x equals. That's what solving means. X equals something, or y equals, whatever the variable is. The method that we're going to use to get to the solution is factoring. And every year I have kids lose half the points on the back of the test because all they do is factor it and they don't actually solve it. Are we clear on that distinction? Any questions about that difference? Okay. So here are the steps that I want you to follow. First off, you need to make sure one side of the equation equals 0. If it's not already done for you. Sometimes it's going to be done for you. Sometimes it's not. That's the first step. Then once we've done that, then it's a matter of actually factoring the equation. Well, it's actually factoring one side of the equation because one of the sides of the equation equals 0, so there's nothing to do over there. You're going to fact the other. So that's where what we did yesterday on that worksheet, you're going to do that. And we're going to do that because now we're going to get this equation into factored form versus standard form. And then this is the part that I showed you earlier. You're going to set each of the factors, once you get it into factored form, equal to 0 and solve. And then you're done. And so these steps you're going to use every single time you have a quadratic that you need to solve. Sometimes this first step is going to be done for you. This is something you should always consider doing after this happens, and then you're good to go. So here are the equations that we're going to practice on. Okay. Now I was kind enough to make one side equal to 0 already, so the first step is done for you. So go ahead and try to solve both of these, and then we'll come back and see how you did. Got a couple things to discuss, because some of you are a little stuck, but a lot of you are in a good place. On this first one, what is the method you should check every single time for every single problem? Greatest common factor, okay? Is there a greatest common factor here? And if so, what is it? Alyssa, what is the greatest common factor? 9x, okay, 9x. So where does that go? On the outside. So I've got a 9x, and then I just have to divide. Okay, so what is 81x squared divided by 9x? 9x. And then this one always gets us. It doesn't say always gets us. Remember that if I start with two terms, I should have two terms inside here. 9x divided by 9x is not 0. And every year I have kids just stop here. What needs to be over here? Minus 1. Okay. Now, this is factored form. Okay. All I've done is step 2. I haven't solved anything yet. We have to solve. So what are my two factors here? What's the first factor? 9x. What's the second factor? 9x minus 1. So my next move is to set each of those equal to 0 and solve them. And a lot of you stopped here thinking you were done. We hadn't solved anything yet. Okay. So what does x equal in this equation? 0. X equals 0. What does x equal over here? 1/9. Okay, I add the 1 and divide by 9. Those are my solutions. That is my final answer. Factoring is the method to get to the answer. Okay? Now, you guys did a good job over here. I saw most of you had this. How does this factor out? X minus 7, x plus 3. Now, you don't have to set them equal to 0, right? Because we learned about this whole opposite sign thing. So here's factored form. What is the solution going to be here? What's the solution going to be here? -3. So you could just jump right to the answer and call it a day. Okay? So the thing that you need to know about what you're going to be working on for the next couple days is that you can use every kind of factoring that you did on that worksheet. And sometimes you're going to use some, sometimes you're going to use others, sometimes you're going to combine them together and do multiple. Okay? So just kind of keep that in mind as you work through these. And keep in mind also that we are solving. The goal is to solve. Factoring is the method to get to the solution.